Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0713, indicates an issue with the transmission fluid temperature sensor, TFTS, which measures the temperature of the transmission fluid. This sensor plays a critical role in the vehicle's transmission control module, TCM, by providing data needed for optimal transmission performance. When the sensor's output voltage surpasses a predefined threshold, it triggers the TCM to flag an issue, resulting in the storage of DTC P0713. This error affects the correctness of gear shifts and overall transmission efficiency. The TF sensor is typically integrated with the solenoid wire harness A and is located near the transmission assembly, making it easily accessible for inspection and testing. Understanding the implications of this code is essential for maintaining proper vehicle functionality and avoiding transmission-related problems in the Honda Accord 2023 and newer models. DTC P0713 refers specifically to the transmission fluid temperature sensor, which measures the temperature of the transmission fluid. This sensor's primary function is to relay accurate temperature data to the TCM to ensure proper shifting and transmission performance. The sensor is integrated within the solenoid wire harness A, which is strategically placed in close proximity to the transmission assembly for easy access and efficient functionality. This integration aids in optimizing the response time for any adjustments that the transmission system needs to make based on the fluid temperature. If the sensor detects a temperature that results in an output voltage exceeding 4.93 volts, it indicates a potential fault within the system. Understanding the location and function of this sensor is critical in troubleshooting DTC P0713 accurately. When diagnosing the causes of DTC P0713, several factors may lead to the elevated voltage from the transmission fluid temperature sensor. A common cause is a faulty transmission fluid sensor itself, which may generate improper readings due to internal failure. Alternatively, an open circuit in the wiring connected to the sensor can interrupt the signal, causing the TCM to misinterpret the fluid temperature and trigger the DTC. Furthermore, there may be a malfunction within the TCM that prevents it from processing the sensor signals accurately, which is also a critical area to investigate. Each of these components plays a significant role in the overall functionality of the transmission system. Thus, identifying the root cause is vital to resolving the issue at hand. The manifestation of DTC P0713 typically results in several symptomatic behaviors concerning the transmission. One prominent symptom is erratic transmission behavior, where the vehicle may exhibit unexpected shifts or harsh engagement. Additionally, drivers might experience delayed shifting, especially during acceleration, which can lead to significant discomfort while driving. The TCM relies heavily on accurate temperature readings for smooth gear transitions, meaning that inaccurate data can cause notable disruptions in performance. Moreover, the engine warning light may illuminate on the dashboard to alert the driver of existing issues within the transmission system. Noticing these symptoms early can aid in prompt diagnosis and repair, ensuring continued vehicle reliability. To begin troubleshooting DTC P0713, the first step involves powering on the vehicle to the on mode, which allows electronic systems to activate. Once the vehicle is in this mode, utilize the Honda Diagnostic System, often referred to as HDS, to check the voltage reading for the CVTF, continuously variable transmission fluid temperature sensor. It's crucial to pay attention to the voltage value. If it registers more than 4.93 volts, it confirms that a fault indeed exists, duplicating the failure condition outlined in the diagnostics. This step is foundational, because it determines whether the sensor itself is indeed the source of high voltage value, or if it is indicative of deeper, more complex issues. This systemic approach is essential in isolating the problem and prioritizing subsequent action items effectively. The second troubleshooting step requires disconnecting the solenoid wire harness A connector, which is an 8-pin, 8P connector, essential for transmitting signals from the transmission fluid temperature sensor. Once disconnected, a jumper wire is used to connect terminals number 6 and number 7 of this harness. By creating this connection, you are allowing for a controlled inspection of the vehicle's transmission fluid temperature sensor without interference from other components. Following this step, the vehicle should again be turned to the on mode. This procedure aims to isolate the sensor and its connected pathways, providing clearer diagnostic results. Confirming the HDS voltage reading after this jumble will help determine whether the issue lies with the sensor or if other components in the circuitry are faulty. Continuing with troubleshooting involves checking the HDS readings for the voltage of the CVTF temperature sensor after completing the previous steps. Under normal conditions, there should be a reading of less than 0.07 volts when the transmission fluid temperature sensor is disconnected. If this voltage is within normal ranges, it indicates that the problem lies with the transmission fluid temperature sensor itself. As a high reading yet again confirms the sensor's malfunction, this diagnostic approach underscores the importance of accurately assessing the output voltage in understanding where the fault might originate. Identifying whether the sensor is defective or if there's an issue in the circuitry allows for precise repair measures instead of guessing at components that may not be the source of the problem. In the fourth troubleshooting step, you will focus on inspecting the wiring related to the transmission fluid temperature sensor. Before disconnecting the TCM, Transmission Control Module connector, it is crucial to jump the SCS, service check signal, line using the HDS and allowing for a waiting period of over a minute. This process establishes a baseline for the diagnostic inspection. Disconnect the TCM connector, which is a 50-pin connector, and the solenoid wire harness A connector again. This stage involves testing the TATF open wire and SG5 open wire for continuity and any possible interruptions. The aim is to ascertain that both circuits are functioning correctly, revealing any potential opens or shorts that might affect the transmission fluid temperature sensor's performance, which directly correlates to the DTC P0713. Once other possible causes have been ruled out, the final troubleshooting step is to examine the TCM. If you have confirmed that the other components and wiring are functioning normally and eliminating those fault possibilities, it's highly likely that the TCM itself is the root cause of the issue. The TCM is responsible for processing the signals from the transmission fluid temperature sensor and making adjustments per the data received. If the TCM malfunctions or fails to process this information correctly, it can cause a cascade of problems, resulting in DTC P0713 being triggered. This inspection involves checking for any signs of physical damage or wiring issues leading to the TCM. Ensuring the TCM operates correctly is essential to restoring proper functionality to the vehicle's transmission system. After completing repairs or component replacements for DTC P0713, the final verification step is crucial to ensure that everything is functioning as intended. Start by verifying the vehicle's operation. Drive it to see if any symptoms previously noted are resolved. After confirming the vehicle operates correctly, clear the DTC from the system using the HDS. Follow this by retesting the system to ensure that the DTC does not reappear. Successful validation means the repairs have corrected the issue restoring full transmission functionality. Continual monitoring may be needed to confirm that no further errors arise after the completion of repairs. This step reinforces the importance of thorough checks in automotive diagnostics to ensure that not only the immediate problem is resolved, but also that long-term solutions are implemented. To prevent the occurrence of DTC P0713 in the future, proactive maintenance is critical. Begin with regular checks of the transmission fluid levels, ensuring they remain within manufacturer specifications. Low fluid levels can lead to high temperatures and erroneous readings from the transmission fluid temperature sensor. Additionally, timely inspections of the transmission fluid temperature sensor itself are advised, as well as the associated wiring, to detect any deterioration or damage before they lead to faults. Keeping the sensor and related components clean and unchecked can further prevent operational discrepancies. These preventive measures not only enhance the lifespan and reliability of the transmission system, but also safeguard against unexpected failures that could lead to costly repairs down the road. In conclusion, understanding the role of the transmission fluid temperature sensor and its integration into the vehicle's systems is crucial for effectively diagnosing DTC P0713. By being aware of the symptoms associated with this code, drivers and technicians can promptly identify and address issues to maintain vehicle functionality. Following a systematic troubleshooting approach ensures each possible cause is assessed thoroughly, leading to more accurate repairs and solutions. Preventive maintenance measures can help mitigate future issues, keeping the transmission system operating efficiently. Ultimately, awareness and action are key in managing and rectifying errors like DTC P0713, thereby enhancing overall vehicle performance and reliability. Please like and subscribe to the channel. See you next time.